volunteer. Two volunteers, one to read the question and one to read the objective before we read our question for today. Great. What are linear equations? Still working on what are linear equations and what is the objective before the trees?
I can rewrite solid equations that are not obvious. Linear equation using property or equal.
Of equality.
Question.
And the class say these two questions. Yeah, Marquis?
Is linear the same thing as infinity?
No. So a linear equation can have infinitely many solutions. Or no solution. Or one solution. Okay? Alright, go ahead and look at the top. How many of you have been into a Memphis Grizzlies game before? Raise your hand. Raise your hand if you've been to a Memphis Grizzlies game before. It's alright if you haven't. Okay? Yeah, I've been to.
Do you have a team that plays basketball?
Oh yeah, do your favorite team play basketball? Some of you
Pretty
do, some of you don't. Put your hands down. Okay, let's say the Grizzlies are having a good season, and their ratio from wins to losses is for every one game they lose, they win 3 games. That's a pretty good season. For every one game they lose, they win 3 games. That's the ratio from wins to losses. Now, let's say they played a few more games in the season, and I told you they played, or they've lost 3 games. How many wins would you expect them to have if they've lost 3 games and you want to keep that same ratio? Jars?
9.
How'd you get 9? Okay, why are you multiplying 3 times 3?
You had said, cause they said 1M equals 3 wins, so I just did 3 times 3.
Okay, so where'd you get this 3 though? Why did you do 3 times 3? Oh, you're saying this 3 represents what? The wins. The wins. Okay. What did you multiply 1 by to get 3? 3. So you multiply the bottom fraction by 3 and the top fraction by 3. That's one way to do it to get 9. Is there anyone else that thought of a different way than multiplying 3 by 3? Anyone? Did anyone have a different number than 9? I never said that was correct. Did anyone have a different number than 9?
Hey, remember what he said. For every one loss, how many wins do I have?
3.
All right, let's look at it and think about that.
Chris?
I had 1.
You had 1? So you just flipped the fraction you thought?
Yeah, because what you said for every 1 loss, you get 2 wins, so for every 3 wins, you get 1 loss.
Okay. Well, let's just use this right here. Watch this. If I have 1 loss, I get 3 wins. So I have 1 loss right here, I get 3 W's.
If you said 1 win, then you said.
If I get another loss, I get 3 W's.
Mm-hmm.
And I'm just using this right here. If I get another loss, I get 3 W's. Count all my W's up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Go. Let's say the Grizzlies are having a bad season, and their wins to losses is 6 to 12. 6 to 12, not very good wins to loss. If they had, for every 6 games they win, 12 games they lose. How many games would you expect them to win if they had 5 losses? You could be totally wrong or totally right. Doesn't matter. I'm not looking for right or wrong. What do you think, Kamen? What do you think, Kamen?
2 wins.
Kamen says 2 wins. What do you think, Marky?
30.
30. What do you think, Patrick?
3.
3. Jars?
30.
You agree with Marquis? What, that tally there? Esley? 2.5.
Ooh, no. I said 25.
Chris?
5, 30,
And I think it's Marquis 30. Khalil?
5.
5. Okay, so 6 times 5, okay. Kevin, where'd you get your 2 from?
Okay, you said 12 lost, but if 12 lost, it's 6 every. So I just did it like this. So every time I use 2 guns, which one win?
Okay.
So I just did the same thing on the other side of this game. 2.
Okay, so every time you win, that's great. So you simplified this down. What is the 6 over 12 simplify down to? 1 half. So this would have to simplify down to 1 half as well, right? Esther, how'd you get 2.5?
I divided 12, I think I was trying to divide 5.
5 by what? By 1 half. So Cayman and Esther onto the same thing, okay? Here's what I want. I'm gonna show you how to do problems like this that are not as easy to see as the one above, and then we'll come back and show us why you guys are right, okay? So, if we're trying to figure out how many games we've won, I can set up this equation right here. 6 to 12 equals, and instead of writing a question mark, I'm gonna write x over 5. And we're gonna solve for x. Here's how we're gonna solve for x. We are going to cross multiply. So I'm going to take my 5, multiply it by 6, take my 12, multiply by x. So that 6 times 5, I'm going to write over here, equals 12 times x. Raise your hand if you remember doing these problems in 7th grade. Remember doing it in 7th grade? Most people today remember doing it in 7th grade. Okay? 6 times 5 is what class?
30.
30. Equals 12x. Deshaun, what do I have to do to solve for x? What operation is happening between the 12 and the x? Multiplication, so what's the opposite of multiplication? Division. What do I divide by? What do I divide by? 12. That goes to 1. I get 30 over 12 equals x. Sean said, Maya, sit up. Sit up! Sit up! What's 30 divided by 12? Put it in your calculator, Mario. So 2.5 equals x, or x equals 2.5. What does the 2.5 represent in this problem, Marquis?
The number of wins.
Number of wins. Esley, you were right on point.
Excuse me, teachers. Trinity Taylor, please report to the main office. Trinity Taylor, report to the main office.
Now you can't really have 2.5 wins, but let's just say that there are 2 wins and they're on their way to win another one. Okay?
You're watching it at home and they're about to win now.
Cayman, do you understand how close you were to getting this right?
This one they said 2 wins instead of 2.
Really? That's on point, Cayman. Yeah. So real quick, Esley and Cayman are on the right track because this. If half of 12 is 6, so this simplifies down into 1 half. So you have to write a ratio over here that simplifies down to 1 half. So half of 5 is 2.5, or half of $5 is $2.50. Marquis, yes.
For the where you working at it, you know where you got a dash between 12x and 12. Is that right there?
Do I do what?
I'm copying this, so I'm saying do stuff like that, like that.
A dash?
Yeah, I'm saying do you
This
got
right
crossed
here?
out so we know, right?
Yeah, that's a 1. I'm writing a 1 there. 12 by 12 is 1. Yeah. Yep. Okay, now we're going to take 7th grade concept and you can go to 8th grade with it. Okay, here's 8th grade concept. Let's go to example 1. Can I get a reader for example 1? Trees, go.
And the diagram for trying to ABC is similar to trying to A prime, B prime, C prime, using what we know about similar terms we can determine the value of things.
Okay, Similar triangles means that I can compare side of their ratios, and they should be equal to each other. Watch it now. AB, I'm going to compare to AB prime, the OG, which is AB, compared to its copy, AB prime. That ratio should be the same as AC is to its copy, AC prime. Alright, similar triangles, we can write these. Let me show with highlighter. So AB compared to AB prime, and then AC compared to AC prime. Question, why did I use the yellow and green side and I did not use the BC side? If we're trying to find X, why did I not use the other side, BC? D'Angelo?
Because
Did not have any information at all. There's no information over here, so why would we use these sides? Don't do that. Waste of time. Alright, and here's what I'm going to do. I'm going to write the expression that AB that is represented by AB. So AB is, right here, x minus 2. X minus 2. Someone tell me, what is AB prime? Raise your hand. What is AB prime? What is that? Thomas, what is AB prime? What's the number, the length of AB prime?
9.5.
There you go, 9.5. And I need someone to write, can someone write the ratio for AC to AC prime? Go for Patrick.
X plus 2 over 12.
There you go.
Love it, love it.
And now y'all, from before, we have the ratio, just like we did before, and we're just going to cross multiply and solve for x. So go ahead and draw your arrows to help you remember to cross multiply. You don't have to draw arrows, I do, just to signify that I'm multiplying. And it's going to look like this, 12 times x minus 2 equals 9.5 times x plus 2. Distribute time. We gotta distribute, solve for x. So Leslie, go for it.
You multiply 12 times x, equals 12x. Then you multiply 12 times 2 and equals 24.
There you go. Can you do this side too, Leslie?
9.5 times x equals 9.5x, and then 9.5 times 2 equals 19.
Perfect.
Great job, great job.
Good job, Leslie. All right, now we have to get x by itself. We have to get x by itself. We have to move to one side of the equation. Amaya, which side of the equation are you going to move x to? Fine. Amaya, stand up. Stand up right now. Stand up. Stand up. Stand up. Get out of your chair. Stand up, please. Horace, what do we do? Combine like terms. How do I combine like terms? I start on my left side, and then I start on my right side. Horace, can I move anything on the left hand side? Can I combine any terms on the left hand side? Okay, but they're on opposite sides of the equal sign. How do I get it over? How do I move it over? Tyler, my Tyler. The left. How do I move to the left?
Put 9.5 on the
This is a positive, what do I do? There you go. Okay. Now you can calculate for this, you can do mental math. 12 minus 9.5 is 2.5x. Minus 20, I'm just bringing this minus 24 down. Equals, this goes to 0, 19.
So what are we still trying to do here? There you go. So every time you go to the step, you gotta keep that in your mind. I'm trying to get x by itself.
Alright, what do I have to do next? This is two-step equations, this is, Chris? Alright, so this is a negative 24, what's the opposite of negative 24? There you go. 0, bring down my 2.5x, 19 plus 24, raise your hand when you got it. You can do it in your head, or you can do it on the calculator. Cameron? 43 is on point. Did you use your calculator for that? That's what I'm saying, man. The mental math just goes boom. Mental math is quicker than calculator.
So we got another equation here again, right? And so what are we still trying to do? Isolated verb, love those big words. So what do we need to do?
Who we not heard from on today? Marion. 2.5x. What operations happen between 2.5 and x?
If we have a number next to the verb, what is that called?
What operation? Addition, subtraction, multiplication, division. Come on, man. Come on. Call someone else, Marion. Okay, what operations happen between 2.5 and x though? Multiplication.
Whenever you have a number next to a variable, that's multiplication.
So you got to divide.
2.5x, and then I had got 17.5.
Good. X equals 17.5. Awesome. Yep. Now we have one more step to this problem. One more step. We found what x is equal to. X is equal to 17.5.
How much is x equal to again, Mr. Berkey?
17.5.
Once again, class, how much is x equal to?
17.5.
So y'all are telling me that x is 17.5, right? Alright, I'm just checking. We're finna find out something.
Alright, listen up. AB. Someone tell me what's the expression for AB's length? What's the expression for AB's length? Patrick. X minus 2. So what would be the actual length of AB if we know what x is? Go for it, Patrick.
17.5 minus 2.
That's 17.2. I'm sorry, I wrote 17.5. My bad. 17.2, what is it?
17.2 minus 2.
Perfect, man. Minus 2 equals what? 15.2 centimeters. There's AB. Now I need someone to do AC for us. AC, someone tell me what's the expression for AC? Mine Peterson? X plus 2. And what is x equal to, Mine P? 17.2. So what would be the length of AC? What's 17.2 plus 2? I think you can do that. There you go. 17.2 plus 2 is 19.2 centimeters. The only thing that is new for us. Can someone tell me what's the only new thing that we we had not seen at all this year. We haven't seen it at all. Hey, D'Angelo, which one? This right here? Okay, yeah, we haven't really had set a ratio up. I don't know, Chris, what? Which one? This is the only thing that's new. We've seen similar triangles, we've seen solving equations, this is the only thing that's new.
And when Mr. Berkey did that, did this part, let's think about our objective. What do our objective tell us to do? What did our objective tell us to do?
Determine
the variable
It said we can rewrite and solve the equation. So what he just did was, he rewrote the equation, and what we did was solve it. We still trying to find out and isolate what? The verb. We're looking out.
I'm gonna give you 4 minutes so you can work quietly together to work on the U-try in the back. Can I get a reader for the U-try before we go into it? Nice and loud, Chris. All right, 4 minutes, you can work quietly at your groups. On your mark, get set, go.
I already heard you talking. Good job. What you got going? Tell me what you doing. Turn it over in the back and look what he started to do. He wrote some letters out there. Extra letters. Is that what you said you did? He wrote matching letters. That's all he's doing. Matching letters.
Notes are on the board as well.
Turn the paper back over.
I know, but
Okay, check it.
yeah, she did. She always said, "Think what you did."
A and B don't got no, what's it called? A and B don't got no links. A and B don't got nothing. Are you gonna be quiet? A and B don't have anything, so we're not gonna highlight A and B.
Which size can we compare?
Ooh, I'm about to tell. I'm about to oh my God, Miss Berkey said stop singing.
Set that right up here.
Marquise.
She keeps singing.
Don't forget what I do.
If he don't have any.
Cross multiply. Then what?
No, for real. I did. How we get the 12? I ain't cause they get
If he don't have anything.
I was just Miss Berkey.
You're gonna do eight, somebody did AC over 80 prime, and you do one more minute left, one more minute.
Hold on, Mr. Garden.
One more minute, one more minute.
I need some wrong one.
Yeah, my bad.
Bring that together in 3, 2, 1, 0. Think of volunteer. Write our ratios of corresponding sides. Just the sides, no numbers or expressions involved. Just the sides. Chris?
So I did AC,
Good.
so I got X plus 4
No, just do AC. Okay, we'll write the expression in just a second.
over BC.
Okay? Now, if you look at the one that we just did, I compared AB to AB prime and AC to AC prime. So what should go right here?
I mean, AC prime.
There you go. Now, Chris, go ahead and write it with the expressions in. So AC is x plus 4.
I mean, X plus 4. And then I said equals the AC prime.
Okay? No, Chris?
I'm not doing it.
No. We're just writing, instead of writing the AC, we're writing the expression.
So I did
Here's one. X plus 4.
Hey, it's too much sidebar talking. Only thing you doing is, we going back to elementary, y'all. Only thing we doing is matching numbers. We matching numbers to our ratio. We had AC and we had AC prime. Why do we choose AC and AC prime instead of AB? All right, then we need to listen up, because we're not having enough people that get this concept. AB don't have anything beside it, so therefore we can't use it.
Got no information.
So we write AC compared to AC prime. Now, we're gonna choose BC over BC prime. Now, we go back to our triangle, and we identify what AC was. Thomas, what is AC? What is AC? Good job. So we're gonna write down X plus 4. That's our AC. Now, Omari, what is AC prime?
Stop with that side talk.
Thank you, 4.5. That's all we're doing. There's too many people that didn't get this concept because we're not paying attention. Then we're going to identify the ratio of BC and BC prime. Horace, talk to us.
It's,
Easy.
3x, 1 and 2, and 9.
Alright. Now, we just set it up. Hold on. Now, we just set up the problem. That's it. This is the only really kind of new part. Not really new. Horace, go.
So, you do 9 plus like a box. Yeah, you probably multiply. So then at the bottom, right now, then you put the upper parentheses, x,
Go.
x plus 4, close parentheses equal 4.5, open parentheses, 3x minus 2.
Good job, Horace. Now, someone else take over.
I got a question.
Go for it, D'Angelo.
Yes, okay, so, and 9 times 8 is 9x, and then 9 times 4 is 36.
Stop right there for me, Dan. What is that call you just did?
Distribute.
There you go, there you go. Good job. Keep going.
And then I had did 4.5 times 3, it gave me 13.5x. And I had did 4.5 times 2, and it gave me 9. And
Don't
then
forget-
I
Don't
had,
forget that minus sign right there. Okay?
and then I had, one keep going?
Yeah, I do want you to keep going. Hold on, let me write it over real quick. Alright, keep going.
And then I had did, well, I had put the 13 times root to the left,
Okay, so how did I move the 13.5 there?
subtract 13.5x.
Why did you move this to the left? What's your goal?
To get the verbal,
Isolate, there you go, okay. So what happens?
and then I had got for 9 minus 13.5, I had got negative 4.5x, and then I brought down my 36, and then I had put equal 9,
Perfect so far.
Equals,
negative 9.
there you go. Alright.
And then
Before, we're gonna have Maya and Tyler take over.
Put negative 36.
That's what I'm talking about. Keep going.
Yeah. Negative 4.5 is. That's 0 again. 36. 13 for 9, 45.
Nick,
Negative.
there you go. Yep.
Divide by 45.
By 45 or negative 4.5. You're trying to get x by itself. Right? Because Mario, what operations happening between the negative 4.5 and the x? Okay. So what's the opposite of multiplication, Mario? Division. So we divide, inverse operation. Divide negative 4.5 on both sides. What do you get, Ms. Tyler? Angela?
I had put the negative 36 on there.
So you need minus 9 minus 36 is negative 45. You have that done?
No,
Same sign, combined.
look, I had 5x plus 36 equal 9, and I had get the negative 36, but the 9 minus 36 is.
Same sign combined. They have the same
Minus
sign.
9 minus 36. Negative 9 minus 36. Alright, still not done. We need to determine the side lengths of AC and BC prime. AC and BC prime. How do I figure out what AC, how long AC is? What's the expression that represents AC? Josiah, what's the expression that represents AC? AC in yellow or green? Yellow. So what's the expression that represents AC? X plus 4, that's right. Josiah, what's the value of AC if the expression is x plus 4? We know what x is. X equals 10, and we have x plus 4. What's AC? What number would you plug in x with?
Whatever number you said was X, that's what I should plug in for X. Isn't that right, Ms. Berkey?
Yeah.
So if I say 10 equals X, wherever I see an X, I should put a 10 there.
So what would be x plus 4 if we know x is equal to 10? Esley? 10 plus 4 is equal to 14. Shouldn't have left by that, man. BC, who wants to do BC? Jarvis, go for BC.
BC says 3x minus 2.
So where would I put the 10 in? What's 3 times 10?
30,
Minus 2?
28.
Where do I put my sign? There you go. On point. That's a lot going on there, but in the end, the only thing that's new is just this cross multiplication. That's it. Who we saying good job to? We're saying good job to Chris, starting it off, Ford, starting it off, D'Angelo, Maya, Tyler, Patrick. I don't know, what did you do, Patrick? You did anything, bro. Who else? Mara did a little something. Jaris. Good job to those people who helped us do that problem. Okay, now our cool down is going to be minus the shapes. And it's just going to be simple. What's the question? What's the question?
Hey, look at the yellow sheets that I gave you real fast. We took a little long today. But on these yellow sheets, this is what I need you to do. Each of the yellow sheets, everybody should have one. On the back, you need to write what's over here on the board. Real short and simple. Look really fast. I want you to write cross multiply and set up equation. Write that on the back. Really fast. Cross multiply and set up the equation. Everybody should write that really fast. This is going to help you solve this problem. Cross multiply and set up the equation. Now, on cool down, check out what your